Okay, so today we're looking at combinations. So our learning intention is to gain the knowledge of what a combination is in probability and the skill in how to apply this to solve problems. So we'll be successful if we can correctly locate the combination button on the calculator, if we can correctly understand when to calculate a combination, and correctly know the difference between a permutation and a combination. Okay, so let's imagine that we have a team of 2 cooks and they're being chosen randomly to bake a cake. And how many ways can this be done? So let's the cooks be Abby and Brian. So a team of 2 cooks from 5, that should say. 2 cooks from a list of 5. Okay, being randomly chosen to bake a celebratory event. In how many ways can this be done? So, let us imagine that we have the 5 cooks, Abby, Brian, Charisse, David, and Edwina. And let's figure out how many possible combinations of 2 cooks we could have. So I've done that. I've kind of jumped ahead and done it. So we've got Abby and Brian, Abby and Charisse, Abby and David, Abby and Edwina, Brian and Abby, Brian, Charisse, Brian and David, Brian and Edwina. So it keeps going. So we have 4 by 5 combinations. Or in other words, we have a permutation of 2 out of 5 people. So this is a permutation. Now, the issue is the order here is particularly important, but really, Abby and Brian is the same as Brian and Abby. It doesn't matter which order they come in, yeah? They're the same combination. So if we go through again, let's cancel out some of the double ups, right? So Abby and Brian's the same as Brian and Abby, so that can go. Abby and Charisse is the same as Charisse and Abby. Abby and David's the same as David and Abby. And Abby and Edwina is the same as Edwina and Abby. It doesn't matter which order they come in. They're the same 2 cooks. So Brian and Charisse is the same as Charisse and Brian. Brian and David is the same as David and Brian. And Brian and Edwina is the same as Edwina and Brian. Now, Charisse and David is the same as David and Charisse and Edwina is the same as Edwina and Charisse, and David and Edwina is the same as Edwina and David. So, what I now have is I have a combination of 2 people out of 5, or 5 choose 2. And I can do this in my calculator by pressing 5, Shift. On the Casio, it's this one above the divide, so NCR. You get the C. Choose 2 people. So I start with 5 people and I want combinations of 2. So I get the solution of 10. So this here is a combination. Okay. So the difference between a permutation and a combination, a permutation so this is when the order is important. And a combination is when the order is not important. So, for example, if I said, in how many different ways could one cook be chosen and then the other cook? That would be a permutation where the order is important. And here it's when the order is not important. So how many teams of 2 could we make? Okay. So A combination is a selection of R distinct objects from N distinct objects, where order is not important. The number of combination is denoted by N choose R, or N combinated with R. It can also be written in brackets N over R. So that the amount that you start with in total is the N, and the amount you want to get, the chosen, is R. And it's also given by N factorial over R factorial N minus R factorial. And obviously R is less than N. Okay, and that is from the NESA Extension 1 glossary. Okay. So let's do some examples. In how many ways can a group of 4 people, so that's going to be your R, be made from a list of 10 people? So N is going to be 10 in this situation. Yeah. So here, obviously, the 4 people, the order doesn't matter. So Abby, Brian, Sharice, and David are the same as Brian, Abby, Sharice, and David. They're the same 4 people. So this would be a combination of 2 people from 5. So 5 choose 2. It can also be, 5 choose 4. R is 4. It can also be written as 5 choose 4. So in this, that's 10. So N is 10. Okay. So 10 is a list of 10 people, and 4 people is R. So 10 choose 4, or 10 choose 4. Okay. So the solution would be 10 factorial over 4 factorial 10 minus 4 factorial. So that's going to be 10 factorial 4 factorial 6 factorial. I'll just write it the opposite way. So if we were to do that in our calculator, we've got 10 factorial 4 factorial 6 factorial, and we get 210. And that's the same as writing it as 10 shift divide 4. We get the same number. Yeah. So the combination button on the Casio FX82 Plus is shift divide. Okay. All right. Now let's look at the second part. If Charlie is one of the 10 people and must be in the chosen group of 4, how many possible groups can be formed? Well, now I have a restriction. I have Charlie has to be in the group. So I'm basically making a group of 4 people. Charlie has to be in the group. It doesn't matter where Charlie is. It could be in the 2nd position or the 3rd or 4th. So really we want 3 people. So now the R becomes 3 and the N becomes 9 because Charlie is one of the 10 people. So what we want to do is now we want to find out what is 9 choose 3. We plug that into the calculator. 9 choose 3, we get 84. So there's 84 combinations where Charlie is one of the people in the 4 group. All right. Next example. How many different hands of 7 cards can be dealt from a standard deck of cards? Well, in this situation, R is going to be 7, because we want to have a hand of 7 cards, and N is going to be 52. Okay, we don't care. You might, in which order the cards get dealt, the hand is the same. Yeah, so you can have 1, 2, 3, 4, 5, 6, 7. That's the same as 7, 6, 5, 4, 3, 2, 1. Okay, and so we want 52. That's what we have. We're going to choose a combination of 7. You can write that as 52 over 7. It's 52 factorial. 7 factorial, 52 minus 7 factorial. Using the calculator, 52, we're choosing a hand of 7, so we get 133,784,560 possible different hands. Okay. So we can also write, so we know that a combination was n factorial over r factorial n minus r factorial, and that's the same as permutation, n permutated with r, divided by r factorial. Okay. So for example, in how many ways can a jury of 12 people be chosen from 30 people? So if we use the combination, we've got 30 people, and we want to choose a group of 12. So we've got 30, choose 12, we get 86,493,225. And let's check if we do a permutation. If we got 30 people and we want to permutate that with 12 different options, yeah, how many 12 different options, and then divide it by 12 factorial, we should get the same answer. Let's try. So 30 shift times, because we want a permutation, so how many different combinations of 12 people, where order is important, divided by 12 factorial, we get the same number, 86,493,225. Okay, so if we find the permutation, divide it by r factorial, you would get the same answer. Okay, so in how many ways can a set of 2 cooks and 3 waiters be selected from 5 cooks and 4 waiters? So if we think of it, we've got, so let's say cooks, and we've got waiters. Okay, so we could say that we have C1, C2, C3, C4, and C5, and we have W1, W2, W3, W4. Okay, so we want to figure out how many ways can a set of 2 cooks and 3 waiters. So really we want, we've got 5 and we want to choose 2, and we've got 4 and we want to choose 3. Okay, so 5, choose 2, we get 10, and 4, choose 3, we get 4. And because we want basically a combination, all we're going to do is going to multiply those 2 solutions, and we get to 40. So there are 40 different ways to select a set of 2 cooks and 3 waiters from 5 cooks and 4 waiters. Okay, 40 different ways. Okay. So a combination n choose r is equal to the same as n choose n minus r. Okay. Basically, the number of combinations of n objects taken at r time is this equal to the number of combinations of n objects taken n minus r. So basically, whatever you take away. So for example, if we had we want a combination of 3 people from 10, that's going to be equal to whatever's left over, the 7 other people left over from 10. Let's check. So calculate 10, choose 3. So 10, choose 3. So it means choosing 3 people from 10, from a list of 10. Okay, so 10, choose 3, we get 120. So if I've chosen 3, there's obviously 7 people remaining. Yeah, so choosing 7 people from a list of 10 people. Yeah, so if I do 10, choose 7, I get 120. And as you notice, they're actually equal. Yeah, so that's sometimes helpful. If you have, if you want to know what's remaining, you can find the combination of what you get to also equal what's remaining. So a group of 5 friends decide to go on a holiday together. 2 of the friends agree to go on the same holiday. Yep, where all the others have different preferences. Yeah, so 2 people have chosen to go to Tasmania, and all the other 3 want to go somewhere else. How many other locations are there to go on holiday? Are there? So if we know that 2 people want to go on the same place, if I do 5, choose 2, I get 10 possible pairs of combinations, but that's the same as if I do 5, choose 3. Yeah. So there's 10 other possible combinations of different places where we could go. And that's how we can use the what's remaining to figure out what the probability is. Okay. So if we look at our success criteria, can we correctly locate the combination button on the calculator? Well, that would be Shift Divide on the Casio FX82 Plus. Understand when to calculate combinations. So combinations when order is not important. Yeah. And correctly know the difference between a permutation and combination. So permutation when the order is important, so we want a specific order of alignment, where combination is when the order is not important. So Abby and Brian, in this one is important because it's Abby's first, Brian's second, but here Abby Brian and Brian Abby are the same. So permutation when order is important, combination when order is not important. Okay, good luck. Thank you.